Hi. So now let us see very important concept in the DBMS subject, and we are going to see actually normalization. So for the before normalization, you have a wonderful concept and very important concept you have to understand. So that is actually this functional dependency actually. Okay. So this is what first of all we must understand. So what is this functional dependency? Let us try to understand in simple manner, and then we will see all the required concepts under this definition, functional dependencies. Then we will see actually the normalization. Okay. So in my words, normalization is very simple and it is nothing if you understand functional dependency concept actually. Okay. So let us try to understand all the things under this functional dependency. Okay. So what is the definition of this one? As name implies, functional dependency. So something dependence actually. So what is that? Let us try to understand. So here, the functional dependency is a relationship, first of all, that exists among the attributes. As we know that in the relation, we are going to have a set of attributes. Okay. So you are going to put some relation among these attributes actually. So what is that one you can see here? So for example, X is a set of attributes and Y is also set of attributes. Set of attributes in the X are deriving set of attributes Y actually. So here X you can say determinant and Y you can say dependent because you are deriving Y from X actually. So that means here dependency is there. That is what. And what is its meaning actually? So wherever X is there, same value of X, then same value of Y you are deriving. Sometimes maybe same value are going to repeat in more than one row actually. So wherever you have X, same value X, then same value of Y you are going to derive. Then only you are able to place this relation X derives Y. So that X is the determinant, Y is the dependent. So for better understanding, so here let us take a simple example here. So let us take this only. X is one column name, that is nothing but one attribute, and Y is also another attribute. So here if you observe, when you can write down this relation X to Y actually, X deriving Y, that you can observe here. Here X, one of the value is X1, that is deriving Y1. So here X1 is deriving. If I ask you X1, what is the Y value? You are going to say Y1. Is it every time? So here you can see X1 is there. In the both those times, it is deriving Y1. And even also here also X1 is there. That is also deriving Y1. And not only just for this one value at the same time. For all other values of X, how many times they are repeating? Every time you must have same value actually. If you observe such a kind of relation, then you can put the relation between two attributes like this. So that you can observe actually for other values. X2, if you observe, X2 is deriving every time Y2, is it or not? So here also X2 is there, so though it is deriving Y2. Fine. And then even X3 also, if you observe, 2 times X3 is there, both the times it is deriving Y3. So then this is valid functional dependency. You can say this is one of the FD in short. So that is what actually, first of all, try to understand meaning of this concept is very simple. In the flow, automatically we will get everything. Okay. So for example, when this condition is false, when this relation is false. So simple, for example, if at least one of the value X1, some value if I took, in all places it is deriving Y1, but in one of the row X1 is deriving, for example, Y2. Then you should not place this relation. That is what, if at least one value, it is deriving different values actually. So here overall you can say X is deriving Y1. In some places X1 is deriving Y2. So it is not valid actually. It is not a FD because Y is not dependent on X actually. So if this is not there, then this is fine. X is deriving Y actually. So hope this discussion make you first of all understanding that when you can use this relation. So to make this understanding more stronger, let us see few examples here. So consider the following relation or which dependency does not hold over R. So this is what the relation are. So over this relation, you have three attributes A, B, C, and corresponding values are also there. He given that four options actually. So whether these FDs are holding over this relation or not, let us observe. Option A is saying that A deriving B. Let us observe A deriving B. So you can see the first thing is when you can say straight away this is valid FD or not. If whatever is there LHS side is always determinant, is it or not? So whatever is there in the LHS side, if it have all values distinct, all values are distinct, you can observe A have all values distinct. You no need to cross check this actually. Because all of them is distinct, definitely whether they are same or different, we don't bother. If there are some places they are equal, like here, x1 here, there, x1 here, also there. At that time, you have to go for the cross check. So that is why, in that way, this is the valid FT, first of all. That means this is not the answer actually, basing on the question. Okay. Then you can see BC deriving A actually. So BC together, that is why we told X is not just a one attribute. X may be a set of attributes. At least one attribute must be there. So now BC deriving A actually. So let us see BC together. So here BC, that together you have to see actually. So here BC and here also BC, there is same combination. So whenever you have the same combination, it must derive same value. Let us check. BC deriving A, here it is deriving A, and here it is deriving D. So this is not valid FD actually, functional dependency. So in that way, that means he is asking which dependency does not hold over R. Yes, this is not at all valid actually. Maybe answer is actually B, you can say. Okay, let us check others also. So B deriving C. Let us see. B deriving C. See, B two times are there here. In both the times it is deriving same value. Yes, valid. And C is there, of course, only one time. So you no need to bother. See, if any value under a particular attribute or combination of attributes, if one time is there any value in the LHS side of LHS side part, X part I am talking. Don't bother about the RHS part actually. If a LHS side more than one time, if it is existed, maybe one attribute or combination of attributes, their combination, then you just cross check actually. These simple tricks makes you more perfect actually. So this is fine, right? So this is also valid FT, you can see. And here you can see AC derives B. So AC, these two you have to cross check. See, values if you see AC, LHS side AC, and here DC, and here EC. See, do you have any repeated combination? No. So straight away you can say again here also, this is valid FT. So the actual answer is B actually for this question. Got it? So in that way, simply you can decide. And let us get familiar of this concept of functional dependency. X derives Y. What does it mean actually? Now let us go for the next one. One more thing, let us try to practice so that things are going to become more perfect actually. So now if you see, consider the following relation R. Which set of the FD satisfy over relation R? So you can see this is the table given now, and these are the four things are given. Actually here, instead of giving one functional dependency, in each option, he given more than one FD actually. So all FDs are if satisfying, then that is the answer actually. So let us simply check. A derives BCD. So here A derives BCD, that is what asking. So here A, this one, A1 repeated here, okay? And here also repeat. So two times is there. do you have the 2 times same value for BCD? B1, C1, D1, B3, C3, D1. That means you don't have RHS part same. So this is not valid FD. So this is not actually the answer. We don't need to cross check BC derives D or not, because one of the FD is not valid. So set is not valid actually, simply, right? So you can cross check also for better practice. Okay, let it be. Now let us go for the B. C derives ABD. So C derives ABD. So you see LHS part C, if you observe, C1, C2, C3, C4, C5. All of them are distinct. That is very important thing. Since all of them are distinct in this FD, LHS part, this is valid FD, because whether repeated or different for the RHS, we don't bother. Okay. Now if you take the another FD, AB derives CD. AB, let us take A1, B1, and A2, B2, A1, B3, A3, B3, A4, B4. So here only B3 repeated, but here it is not repeated, so that every combination is distinct again. AB is the, every combination is distinct. So this is also valid FD. Let us go for the third FD actually. A derives D. Let us observe A. A1, A2, A1, A3, A4. So A1 is 2 times. In those 2 times, observe D. D1 here, and here also D1. Okay, in this way you can see. So D1, and here also D1. Wherever you have A1, those places D1 and remaining are distinct. Remaining are there one time only. So that is why this is valid FD. So answer is this one. All FDs are valid actually. So option B is the correct one. So you can simply cross check this also. This is repeated FD, above also there. So you can go for the next. You can take the AD derives B actually. So AD derives B. Let us cross check AD. So AD derives B, he is saying. So AD combination, if you take A1, D1, 2 times is there. In both the times, is it deriving same value? Let us check. So here B1 deriving and here B3 deriving. So don't confuse with these lines. So one time it is deriving B1 and another time it is deriving B3. So it is invalid FD actually. So this also not correct, and because already we find the answer, option B. So overall, these two questions especially is given for get the familiarity of this concept actually. What are the valid FDs? What is meaning of FDs? How to find the FDs actually? Okay. So this is what overally the functional dependency is a relation among the attributes actually, that you are going to derive basing on the either you have the values basing on the values, or in future basing on the in future whatever you are writing basing on that, now only you will derive actually. Okay.